Hey everyone, welcome to the Pre-algebra 10.6 video. We are talking about surface area of pyramids and cones. Alright, so first let's talk about the vertex of a pyramid. What is the vertex of the pyramid? Well, that's actually going to be right there, okay? So it's the point where all those lateral faces come up and meet. It's the top of the pyramid, okay? Now let's talk about pyramid height though, okay? So it's a line that's perpendicular to the base that reaches the common vertex, okay? So it's if you were to walk inside this pyramid, okay, we went directly to the middle of this square, okay, and look straight up, that line that would be formed by your, essentially your feet to the top of that pyramid is called the height. But then we also have what's called the slant height. Okay, you can think of slant height because the sides of the pyramid are slanted, right? So it's just the height of the triangles that form the lateral faces. So that has a slant height. There's a slant height there. There's a slant height on that triangle, slant height on that triangle. There you go. And what we need to know is that pyramid height, okay, so this middle height, you could think of it, is we use the variable h when we talk about that. Okay, in the slant height, we use the variable L. Okay, so H for pyramid height and slant for the, and L for the slant height. You could think of, trying to remember that, as L is slant height because SLANT, I don't know if that helps or not, or L for the height of the lateral faces. All right, so let's talk about a real pyramid. Okay, so at Cal State, California State, in Long Beach, there is a building they call the Pyramid, and it is actually an athletic facility, and so it's pretty cool. And it has the following dimensions. Each length of the base is going to be 345 feet. Okay, so that's 345. That's 345 on the back side and on the side there. Okay. Now also the height, which remember we use what variable? H, right? Pyramid height. So that's the middle height right there. The height of this, I'll do it in blue. No, we won't. We'll do it in black. What color did I use up there? Okay, black, yeah. Okay, so the pyramid height, okay, so not the slant height, that right there is actually 192 feet, all right? And here, what we know is that from that middle, very middle of the pyramid, out to one of the sides, that distance right there is going to be 172.5. Okay, 172.5 feet. Okay, so look what I formed. We have a height there that's perpendicular to the base. So if I have one line that's perpendicular to another line, I formed a right triangle. Does everybody see the right triangle that's formed there? Okay, because we also know that there's a slant height that's formed right there. So we have a right triangle. But what we want to do is we want to find the slant height. Okay, I want to know how high is it if I were to kind of go on the pyramid here on the outside, and if I were to start right there and I were to run or walk or climb up to the top, how tall is that? Well, I have again, a right triangle that's formed here, and if that's the case, I can use the Pythagorean Theorem. So I'm going to draw just this triangle isolated so that we can just focus on that for a second. All right, so that just came from our original, the original picture here. All right, so again, we formed a right triangle here. Okay, so this is like the outside of the pyramid. Again, it's like if I started down here at the bottom and I ran to the top, we're finding that height. Okay, so how do we do that? Well, it's a right triangle. I want to know the height. And in this case, the height is this side right here, which is directly across from the right angle. Therefore, we're finding the hypotenuse. So I need to use the Pythagorean Theorem. Pythagorean Theorem. And what does that state? Well, again, it states that a squared plus b squared, and I'll do this in blue, equals c squared. Okay, so we're finding that side. So what does that mean? Well, let's see. A squared is one of the sides, or the legs of the triangle. B squared is the other leg, and then I take that, and it's going to equal the hypotenuse squared. So we'll call this A right there. So we'll take 172.5, and we'll square it. And we'll add that to B squared, so we'll call this right there b. So we'll take 192, we'll square it. And what we're saying is that has to equal the length of the hypotenuse squared. Well, do we know the hypotenuse? No, so I'll just use c squared. All right, so let's see, what do we get? Well, 172.5 squared will get you 29756.25. We'll add that to 192 squared, which is 336,864. And again, that has to equal c squared. I should have had a comma right there. All right, so if I add those two things up, what I end up getting is 66620.25. And again, that equals c squared. Now, I need c by itself because I'm looking for that length of that triangle there. That's c. How do I do that? Well, let's take the square root of both sides. And so the square root of our answer, or of 666,620.25, that equals 258 approximately, equals c, because again, the squared inside a square root cancels. So we have just found that if you were to go to the pyramid and were to start perfectly in the center of one of the sides and run or climb or walk up the top, it would be approximately 258 feet. Right there. All right, so let's talk about the surface area of pyramids, okay? And we just learned how to find that length of the hypotenuse, otherwise known as the slant height, okay? We just learned to find that because we need to know that when it comes to surface area of pyramids. So again, what is surface area of pyramids? Well, it's all those sides you can see and the base and all the area of those added up, okay? So what we could say is the surface area of a pyramid is equal to the base area plus the lateral area, okay? And so we've talked about lateral area before. Again, the lateral area in this one would be these sides of the pyramid, right? And that's the lateral area. If you add all those up, and of course you have the area of the base, that would also factor in, and that would be into the surface area. Okay, so the area of the base plus the lateral area. Okay, simple as that. So what we would then want to do is say, well, if I had a pyramid, what would that look like as a net? Well, as a net, we would have our base, and for a regular pyramid, it'd be a square. And then we'd have triangles that unfolded on all those sides. And you can tell that if you were to take these and fold them back in, that you would end up getting a pyramid, of course. Okay, so one of the things we know about a regular pyramid is that all of these sides are congruent. Okay, so what does that tell us? Well, it means the bases of all these triangles are also the same. All right, and in a regular pyramid, the height of these triangles is going to be the same as well, okay, or the slant height. All right, so we're going to work on calculating the surface area of a pyramid, and this is actually a regular pyramid, so this is 10, that would also be 10, that back side would be 10, and then that other side of that base would also be 10. So how do we do this? Well, again, let's think about what this looks like as a net, okay, this pyramid as a net. If you unfolded it, you'd have a square base that, again, is 10 by 10 by 10 by 10. It's a terrible 10. And that's not much better, but okay. And then we'd have 4 triangles, okay? And, well, as it turns out, all the sides of those triangles would also be 10, right? Just like the sides of the square are 10. So 10, 10, 10, 10, however you want to label it like that, it's fine. And let's see, well, the slant height here was 13. So what that means is that the height of all these triangles is also 13. Same there, same there, same there. That's not exact, but you get it. All right, so they're all 13. So how do we find the surface area of this pyramid? Well, let's start by finding the area of the base. Okay. I'll put a little box there. That'll be our answer. Okay. So the area of the base. Well, it's the square. It's 10 times 10, so it's 100. We're talking about centimeters, so it's 100 centimeters squared. All right, but now let's talk about the lateral area. Okay, so what is the lateral area? Well, it's all the area of everything that's not a base. So we've already found the area of that, so we only have 4 triangles left. So how do we find the area of these triangles? Well, let's think about it. That's the base of that triangle, that's the height of that triangle. So we know the area of a triangle is base times the height and divided by 2. So I just have to do 4 of those, right? So the base is 10 times the height, which is 13, and we divide all that by 2. So the area of one of these triangles is, let's see, 130 divided by 2, and that'll get us 65. And we're talking about centimeters here and area, so it's centimeters squared. So 65 centimeters squared. So we found the area of all the parts. Oh, but wait, have we? No. This is 65 centimeters squared for just one of the triangles, but we have 4 triangles, so we need to get rid of that. And that is true, that is 65 centimeters squared per triangle, but we have 4 triangles. So we'll take that times 4, okay, that's 20, 24, and then 26, so 260 centimeters squared. That's not a squared. I'm using a different stylus today and I don't like it. Anyway, so to find the total area, we're just going to add those things up. So 260 plus 100 would be 360 centimeters squared, and that is the surface area of that pyramid. All right, so now we're just moving on to cones. Find the surface area of cones. And of course, the most famous one is definitely the ice cream cone. Who does not love the ice cream cone, especially the waffle cone? Absolutely delicious. So on a cone, our base, as we all know, is a circle, right? And we know that all circles have a radius. Okay, so we'll call that guy a little r, like normal. And we also have a vertex, okay, at the cone where the lateral area comes together and meets. And then we also have a what we call a slant height, right? So just like with the pyramid, right? This was the slant height there, like the outer height. If you were to climb up the side of the pyramid, that's the slant height. Same thing here with a cone. If you were to climb up the side of the cone, you would have what's called a slant height. And again, we use L when we talk about slant height. All right, so when we talk about surface area, again, we want to think about the net. So what would the net of a cone look like? Well, if you kind of peel back the base, you'd have a circle, all right, and then you would also have kind of part of a circle there, part of the circumference of a circle, and then this, okay, so that's what a cone would look like if you split it down the center and peeled it back. So we obviously have a base here, and then everything else that's not the base, again, is called the lateral area. Okay, so our base of the circle is going to have the same radius that it did when it was in its cone form, right? So we'll still have a radius, all right? Now let's think about the dimensions of this lateral area, though. Well, we know that this distance from here to here would be the same as if you took this base, the circumference of this base, and maybe you cut it right there, and you peeled it back that way and peeled it back that way. So this right there would actually be the circumference. That's the circumference of that circle there. All right, and then this lateral area, well, what's the side length of that lateral area? Well, it's actually going to be the slant height, which came from up there. Okay, slant height, and again, we say that's L, or slant height. So again, when I mean lateral area, I mean the area of that whole kind of semi-triangular shape. And when we want to find the area of this lateral area, the lateral area, I should say, that is going to be equal to, okay, so this lateral area of a cone is pi times the radius, and that radius comes from up there, times L, and that L comes from the slant height, or that height right there. So let's go ahead and use this to find the surface area of this ice cream cone. All right, so we'll take this cone. I'm going to make a duplicate image of it. You do all that. All right, so let's talk about this cone. Find the surface area of this cone. Well, as a net, what would it look like? Well, we have a circle on top. That's a terrible circle. And then we have that. Okay. And so let's see. Let's find the area of this base first. Okay. Well, they tell us that the diameter is 48. Okay. And so that means the radius must be 24. And so finding the area of the base, we're just finding the area of a circle. And so that is, area of a circle is pi r squared. So that's like saying pi times 24 squared. And 24 squared is 576. So that's like saying pi times 576, which is equal to, and I'm around to the nearest tenth, 1809.6. Okay, so there's our area of the, and we're talking about millimeters here, millimeters squared. So that's the area of the base. So now let's talk about this, and what is this called again? The lateral area. Okay, so how do we find the lateral area? Well, let's go back. Okay, so it looks like it's pi times the radius of the base times the slant height, pi RL. So let's go back here and write that. We know that that area is going to be pi times the radius times the length. Okay, so let's see. We know what pi is, so we can move on from there. But what's the radius? Well, the radius comes from this circle up here, and it's 24. So we'll be taking pi times 24 times, then what's the slant height here? Well, we go to the cone in the original picture, and they say it's 115 millimeters. Okay, that's the slant height. So let's go ahead and do that. So pi times 24 times 115. I'm going to do the 24 times 115 part first. So that's like saying pi times 24 times 115 gets you 2,760. And if you take that times pi, what you end up getting to the nearest tenth is 8,670.8 millimeters, and we're talking about surface area, so squared. All right, so that's the lateral area. So how do we find the area of this entire cone? Well, it's kind of a trick question. Did we actually need to find the area of the circle up here? Well, think about it. A cone is what? Well, it's hollow. It doesn't have a flat top. It doesn't have a top at all. So actually, the area of a cone is really only the lateral area, if we're talking about an ice cream cone, right? So let's pretend maybe for a second this ice cream cone does have a flat top, right? Which would be kind of pointless because you couldn't put any ice cream inside it. You can only put ice cream on top. Either way, if you wanted to find that, you would obviously add those two things up. But if you were really finding the surface area of a true ice cream cone, it would just be the lateral area right there, and you'd be done. All right, y'all, that's all I have for you. Look forward to seeing you in class, talking more about surface area of pyramids and cones.